So, real quick again, C moves it up or down, A is your amplitude, stretches it taller, squishes it down shorter. B is the same thing as the period as it has been, so we're stretching or condensing horizontally. And then D is just, it's called a phase shift. It's literally picking your graph up and moving it left or right. Okay, so those are the pieces. So when we look at example 2, we just kind of have to figure out what's what. Okay, so do I have a C in this? In other words, am I adding or subtracting something to the whole function? No. So I'm not going to do a vertical shift on this. I'm not moving it up or down. Okay, so C, there isn't one. I don't have to worry about it. Okay, well, what's up with this -2? What is that? That's A. That's changing my amplitude. So I'm going to be shifting between -2 and +2. Since it's negative, I'll start down at -2 and I'll work my way that way. All right? And then I have x minus pi over 3. There's nothing in front of the x, which means that my amplitude, I'm sorry, the period, or what's B? What number is really here? A 1. So it's just my normal cosine graph, which normally has a period of 2 pi. Right? If B is 1, I just do 2 pi over B. If B is 1, the period's still just 2 pi. So it's my normal cosine graph, but so far I'm going to be oscillating between -2 and +2, and then this thing does something else here. This minus pi over 3. Yes, that is, if you look at the formula, right, that is in place of D. And we said that D shifts you left to right. So D in this case must have been a positive pi over 3, right? Because to put it in the formula is a minus. So you really want to think about I know it says a negative right there, but in order to make it a negative, it must have been a positive pi over 3. Does that make sense? So what we are going to do is we are going to shift pi over 3 to the right. So once I go ahead and I'm going to lightly, so at first I'm kind of going to ignore D for a minute. I'm just going to sketch, just like I did on the quiz, I'm going to sketch this graph, y equals -2 cosine x. Once I get that graph, then I'll just go ahead and do that shift. And if there was a vertical shift, I would do the horizontal and vertical shift at the same time. So I'm going to sketch this basic graph just like I did on the quiz, and then I'll pick it up and move it. Okay, so you guys all know how to do this because you did excellently on that quiz, so I know you know what you're doing. Now, some of you, I heard you talking, were thrown off about this part over two periods. All that means is on your quiz, for example, this is one period of that graph. They just want to see a second one. That's all. So they just want to see 2 of those cycles. I'm not that concerned if you mess that part up, but that's what they wanted. Okay, so if I want to go 2 periods, do you want both to be, it's up to you. Do you want to do 2 positive periods or 1 positive, 1 negative? Let's do a positive, negative. I know I said it would be your choice and then I made the decision for you, sorry. That's like when I ask my husband where he wants to go to dinner, but I really know where I want to go.
So you consciously know that you do that.
I do, but I want him to say it because I don't know. Why is that such a thing? Like, why can't people just say where they want to go to dinner and just be done with it? I don't know. So, we're going to graph this like normal. So first, I have to figure out the period, but we already know it because it's just 2 pi. So, let's see. So I'll do 2 pi there, and then I'll just get my second period in the negative. So that'll get me the 2 curves on one graph like they wanted. So we'll be happy with that. So if that's 2 pi, then halfway would be pi, right? And then what's this point? Pi over 2. And then this one would be 3 pi over 4. By the way, that one's a 4. Your sine and cosine curves are on your reference sheet. Just the basic one. Oh, yeah. Just the basic one. So you can just, with its quarter points and everything. So, FYI. All right. And then I'll do in the negative direction. So I'll have negative pi over 2, negative pi, negative 3 pi over 2, 4, I mean, negative 3 pi over 4, and negative 2 pi. All right, so this time I'm oscillating between negative 2 and positive 2, right? So there's 1 to 2, negative 1 to negative 2. So I'm going to lightly graph my normal function, and then I'll worry about this shift part. So negative 2 cosine x. So I will start at negative 2, cross the x-axis, up to 2, cross the x-axis, and back down. Okay, so there is one period, and then my second period I can just do it on the back side. This is too pointy for my liking. Okay, so is that all right so far?
Should that be
Yes.
pi over 2?
Which one?
The third quarter time?
No.
No, because you do pi plus 2 pi is 3 pi, and then,
Times a half.
oh yeah. Oh, you're totally right. Guys, I'm wrong. These are over 2's.
I knew it.
Sorry.
I knew
Well, I'm glad. Okay, thank you. Okay, now guys, all I have to do is pick it up and move it pi over 3 to the right. Here's where you hit a little bit of a snag. Pi over 3 isn't one of my points. If it was, it'd be really easy. Pretend for a second it was pi over 2, right? Okay, pi over 2. On my grid, that's 2 boxes, so I would just shift everything 2 boxes. Well, it's not always going to work out perfectly for you, sorry to say. But sometimes you got to do a little bit of work. Pi over 3. So you have a couple of options. Here's one option, okay? Pi on my grid is 4 boxes. So pi over 3 would be how many boxes?
Well,
Wait, can you
is
say
it just
that?
gonna be,
Yeah,
it's gonna be a little
pi-
bit more pi over 2, right?
Hold on.
Pi is 4 boxes.
Yeah.
So it takes 4 whole boxes to get me to pi.
Yes.
So pi over 3, or 1/3 pi,
It'd be 3 boxes.
No,
that would be
one-
3/4 pi.
1.5.
Now 1.5.
This is a trick.
1/3 of 4.
We're all falling ready for this track.
What's 1/3 of 4?
I don't know. 4/3.
4/3, which is 1 1/3. So what I need to do is shift all my boxes every point 1 1/3 box. Okay, all right. I said there was 2 ways. Relax. So that's one option. One option is you could think in your head, okay, come up with your scale, yeah. So let me just recap because guys, I didn't do any math that's like beyond your years here. 1, 2, 3, 4 boxes for me to get to pi, right? Maybe your scale is different. Maybe you use 6 boxes to get to pi. I don't know. Look at your grid. I don't know your life. Look at it. I have 4 boxes on my scale. 4 boxes represents pi. I need to move everything 1/3 pi, right? That's 1/3 pi to the right.
Yes.
So I need to go 1/3 of 4 boxes, which is a box and a third. And I shift them all to the right, a box and a third. Your other option, ladies and gentlemen, remember that pi is just a number, right? 3.14. You could literally just do it in numbers. Yes, this 0.2 pi is really 6 point, yeah, whatever.
Pi by 3. Can I figure out the number of pieces?
Yeah. Yeah, if you're going to do it all in numbers. So if I'm literally converting these to numbers, so like 2 pi, 2 times 3.14, 6.28. I don't know why I even had to do that out. So anyway, that's 6.28. Pi is 3.14, right? And you want to move it 1/3 pi. So 1/3 times pi. You want to move it, oh wait, I messed that up. 1.047 over. Well, I mean, you can put in your numbers and then you can do it that way. I don't think that's any easier. I think that takes way more time. Usually you're going to get lucky and you're going to be like, oh, sweet, I got to move it pi over 2, and pi over 2 is one of my scale units anyway, so then I just shift it. If it's not, again, we're approximating here. I'm not pulling out a ruler and make sure that you did 1 1/3, but it's going to happen. So you're going to have ones that don't come out nicely, and then you just got to figure out, according to your scale, how far would you move it. So I need to go a box and a third to the right. So my new high point will be there. This point is now here. So everything is just shifted a box and a third. And let's see if this kind of works. Box and a third to the right. Everything. A box and a third to the right. Yeah, everything. Box and a third, box and a third. So, oh, you can't really see it, but
If we get one of these like on a test or something, do we have to write the original one down too?
Can you do it without
Because
doing
I
the
already
original?
can't read one.
yeah, you can do it without drawing the original. Yeah. If you wanted to, that's totally fine.
Yeah, that's all.
Yeah. So, just to make sure everybody's clear, the question was, do you have to have the original drawn? Like, if this were a test question, if you don't have the original, that doesn't matter. So, just your final graph matters. If you want to leave them both, that's fine. Just make sure you indicate to me which one's the original and which one's your final. So, I would just say this is my final graph, the pink one. If you're using both the same pen, just draw me an arrow, which one's your final, which is your original. Okay, so yes, normally it's easier because the shift, well, I shouldn't say normally, usually you get lucky and the shift is one of your units. So you're like, oh, okay, it's 3 boxes or 4 boxes or whatever it is, and you just shift it. But sometimes it doesn't work that way. I can't pretend to you like every number comes out nice, because they don't. This is real world, people. So, let's try the next one. Let's see how we can finagle with this. All right? So, ooh. Let's see.